Imagine being known for something you did over 2 centuries ago. That's the legacy of Thomas Young, the English polymath who first conducted the double-slit experiment. Born in the late 18th century, Young was a man of many talents, a true polymath dabbling in medicine, music, Egyptology, and of course physics. His insatiable curiosity led him to investigate light, a voyage that would cement his name in the annals of science. Picture an author penning a novel that becomes a classic, read and reread by generations to come. That's akin to what Young achieved with his experiment, not just a passing footnote, but a key chapter in our scientific narrative. His double-slit experiment, conducted in the early 19th century, was not just a demonstration of light's wave-like behavior, but a foundation stone upon which the towering edifice of quantum mechanics was built. Just as a timeless novel, Thomas Young's double-slit experiment remains a pivotal point in understanding our universe. Now you may be wondering, what is this double-slit experiment all about? Well, let's imagine a serene day by the pond. You pick up a pebble and toss it in. The moment it hits the surface, it creates ripples, concentric circles of water spreading out, yes? Now, suppose you throw in 2 pebbles close to each other. Each pebble creates its own set of ripples, and these ripples interact with each other. Where a ripple from one pebble meets a ripple from the other, they either combine to form a bigger ripple or cancel each other out. This, my friends, is called interference. Now, let's take this idea to the world of light. The double-slit experiment, first performed by Thomas Young in the early 19th century, is like our pebble-throwing scenario, but with light. Young shone light through 2 slits close to each other onto a screen. If light were just particles like tiny bullets, we would expect to see 2 bright lines on the screen, right? Each line corresponding to 1 slit. But that's not what happened. Instead, Young saw a series of light and dark fringes. Much like the ripples caused by our pebbles in the pond, this suggested that light wasn't just behaving as particles, but also as waves. The light waves from one slit were interfering with the waves from the other slit, creating a pattern of light and dark fringes. But here's where things get a bit mind-boggling. When scientists repeated this experiment with electrons, tiny particles, they observed the same interference pattern. Even when they fired electrons one at a time, as if throwing single pebbles into our pond, the pattern still appeared. This suggested that each electron was somehow going through both slits at once and interfering with itself, a phenomenon that defies our everyday understanding of the world. So the double-slit experiment is a bit like throwing pebbles in a pond, only that instead of water ripples, we're dealing with particles and waves of light. But how does this connect to quantum mechanics, you ask? Well, let's put on our quantum boots and take a leap. The double-slit experiment didn't just ruffle the feathers of classical physics, it turned the whole roost upside down. It introduced us to the concept of superposition in quantum mechanics. Now imagine a coin. When you flip it, it's either heads or tails, but before you catch it in mid-air, it's neither heads nor tails, it's both at the same time. This is the crux of superposition. Quantum particles, like that coin, are in multiple states at once until we measure them. Yes, you heard right. And the double-slit experiment was the first to show this. It demonstrated that particles can exist as both particles and waves, and that their behavior changes when observed. So, the quantum world is a bit like a coin flip, only a tad more complicated. Just like a coin flip, particles exist in multiple states at once until measured, thanks to our friend the double-slit experiment. The double-slit experiment opened the door to the weird and wonderful world of the quantum mechanics. This experiment, as we've seen, has paved the way for us to explore the seemingly impossible. Just as one might travel to a new city, filled with unknown streets, captivating architecture, and uncharted territories, so too is the journey into the realm of quantum mechanics. It's an adventure into the unknown, where the rules of classical physics are bent and sometimes broken. Quantum mechanics is not just a niche area of study for the science-minded among us. Its implications reach into the very fabric of reality itself, inviting us to question everything we thought we knew about the universe. From the peculiar behavior of particles to the concept of superposition and even the baffling phenomenon of quantum entanglement, there's so much to discover. So are you ready to delve into the intriguing world of quantum, where particles can be in two places at once and teleport through barriers? The journey is just beginning.